when I came to the company, I was like really kind of passionate around, boy, we're missing a great automation story. And at the time they said, oh, no, we do have an automation story. I said, well, where? And they said, well, here. I said, where? I said, here. I said, well, no, that's not really what admins think of in terms of automation. Because at the time, the automation was very focused in on, very programmer sort of abstraction, VB script, JavaScript, et cetera. Lots of get an object and then plunk, 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 plunk. Whereas for admins, they have a very clear notion of what automation is, right? Automation is, I get in front of a machine, I have a command line interface, I type it, what's going on? Type it, what's going on? I type it, oh, that's what's going on. And then you take that stuff and you put it in a file, and then you run it every hour or whenever you have some occasion or whatever. And there we were pretty weak. And so I said, hey, we can do better.
So you're, did I detect you're aiming at IT professionals rather than hardcore developers, or are you trying to aim at both groups?
Both groups. I mean, basically, we've been pretty weak on the command line. Okay, so now the question is, who's the command line users? And they are admins. We're really focused in on admin automation, but developers use it, power users use it, tinkerers use it. I mean, it's the tool that people really love to go explore their system, and then once they've figured out their system, then automate it.
Right. I don't even know where to start because I don't have any concept of what that is.
Okay.
I've heard rumblings that it's the coolest thing that
they're correct. It is.
Seeing at the PDC, and they were happy to finally see Microsoft taking this approach because some of the other operating systems out there had a better command line, like you were talking about, than we do.
Right.
But what is it?
Okay, so here's what it is. Basically, it all started as I started to do a deep rethink of the Unix composable management space, right? A pipe to B, pipe to C. And I sat back and I said, why do people do that? What's really going on here? And I figured it out. A doesn't do what they want it to do. If it was, they just type A. So then the question is, well, why doesn't A do what you want to do, right? And there are two answers. First is, well, that's the traditional model, right? In Unix, you say, hey, we don't try and solve your scenario for you. We know we never can because the scenarios are continually changing. So instead, what we do is we deliver you a set of tools, and then you can take those tools to compose unique solutions to your novel problems. Right? So you give them A and B and C and let them stitch it together. And then tomorrow when the scenario changes, they just do A pipe to B, pipe to D. So it works out really well for them. But there's another answer. And the other answer is the heart of this project. The other answer is the reason why you pipe A to B to C, why A doesn't do what you want it to do, is because it tightly binds three separate steps into one step. Okay? A gets a set of objects. It processes those objects, and then it outputs the result, typically as text. And so then when you pipe it to B and to C, what you're really doing is you're taking that text and you're trying to engineer your way back to the original objects because you didn't get the right ones, you didn't process them the way you wanted to, or you didn't output them the way you wanted to. So the observation was, geez, you're spending all your time doing all this prayer-based parsing, right? Cut off 3 lines, go over 27 columns. Sometimes when I do this switch, it's 4 lines. Well, let's just pray it's 3. Let's go over 27 columns. I'm going to pray that there's not a tab there. I'm going to grab this thing, and what the hell is it? Well, I'm going to pray that it's a 32-bit unsigned integer, because that's how I'm going to use it, right? And it works pretty well, but you spend all your time thinking about how you're going to get stuff done instead of getting stuff done.
Right.
And so I was doing this deep rethink as I was looking at the .NET APIs and .NET Reflection, and I said, oh my heavens, we can do better here. We can do great. In fact, instead of having pipelines of text, what we can do is to have pipelines of objects. And then when you want to access some method, some property on the object, just ask for the property instead of having to do all the parsing. So you see what we've done is we've produced a model where all that parsing goes away and people are allowed to think about the problem that they want and just type it and they get it. The power is extraordinary.
What would you say to a semi-advanced user like me, who, or even I know lots of developers who haven't used command line in years, right?
Sure, there's a couple reasons why, right? One is, oh my heavens, it's a pretty frustrating experience, and the other is, hey, if the GUIs are great, people love GUIs. The problem's been, and we love GUIs. The problem's been that there's the GUI experience, and then there's a different CLI experience, and there's stuff you can only do in the GUI.
Command line interface.
Command line interface. There's stuff you can do in the GUI that you can't do in the command line. There's stuff you can do in the command line that you can't do in the GUI. And then when both of those run out, well, then you're into Visual Studio, and you just have to roll up your sleeves and write system code. And so we understood that phenomenon from the beginning. So we said, hey, you know what we want to do is to have a progression, right? A layer. So we are going to have GUIs. We love GUIs. That's what made Microsoft great. We're not walking away from that. But those GUIs ought to be layered, admin GUIs ought to be layered on top of the command line interface. So there's nothing you should be able to do in a GUI that you can't do from the command line.
Right.
So too, at some point, the command line, you'll see we're extraordinarily powerful. Extraordinarily powerful. More along the lines of Perl, Python, Ruby than KSH and Bash. We're as interactive as those, but we're as programmatic as the others. In fact, more so. But at some point, you're going to run out of steam with those, and you want to go to a systems programming language like C#. And so what we did was we took as our design center being a part of that glide path, right? So our commands are classes, they're not standalone processes. What that means is it allows them to be very lightweight, very low latency, to be able to layer GUIs on and get rich, highly interactive GUIs. So too, we went and took our control structures. You know, we designed the language for the fact that eventually you're going to want to do this stuff in VB or C#. So if you take a look at the scripting languages, they often have these kind of wacky control structures, right? If gets terminated by a phi, right? FI instead of IF. And then case gets matched with an ESAC. Now notice, do is not matched by OD, it's matched by done, so there's some inconsistency there. And then other languages, you have a while, which is ended with a when, right? Just wacky stuff, right? We said, hey, you know what? People aren't confused, they aren't nonplussed by squiggle brackets, and squiggle brackets are what you're going to use when you make the shift to C#. And so we said, hey, let's just adopt those. So too, we adopted the similar syntax.
Smooth learning curve into C#.
Exactly. In fact, our GUI, what we want to do, you do use the GUI, yeah, I'm getting along, and if that meets your needs, you just stay there. But at some point you say, hey, what the heck's going on here? You ever ask yourself that question? You're doing a GUI and you're like, if I wanted to do that, what's really going on? And right now you don't know, it's completely opaque. So by layering the GUI on top of the CLI, we'll have a button say, what the heck? And you click that button, and as you click around, it's going to show you all the command lines that are going on. And then you say, oh, well, I like that, but that's not quite right. What I'm going to do is I'm going to take that now, I'm going to turn it into my own script. I'm going to add my own policy or whatever, and you do that, and then you say, now as you're doing that, as you're using the scripting language, what you're learning is the .NET objects, the C# control structures, etc. And you say, oh, this is great, but you know, I need maximal performance. I need a little bit more. You know, I got to turn this to 11, right? And you say, hey, now I go into C#. And now all your programming skills, all your knowledge, all your use of the frameworks and the objects all help you make that transition. So basically designed it from the get-go to do that.
When somebody, first of all, how do you get Monad?
How do you get Monad? It's available on BetaPlace. So if you go to betaplace.com, right, you have to have a Passport account, but then you log in with MSH PDC, case matters, it's lowercase MSH, Microsoft Shell, and then uppercase PDC, Professional Developers Conference, and you'll you log in with that, and in 24 to 48 hours, you get a copy of it. Yeah.
So it's not a Longhorn specific technology?
No, not at all. It's a .NET specific technology. We leverage .NET from the very beginning through everything. .NET is just such a wonderful environment. I mean, the thing is that with, you know, if you take a look at management, right, you can say, I've been in management most of my career, and I think it's a fair assessment to say we haven't...
Computer, not management of people.
Exactly, exactly. I think it's fair to say that management has not exceeded customers' expectations, right? And what's going on there, right? Are we idiots? Are we stupid? Are we lazy? And the answer is no. The problem with management is that it's always been outside of the mainstream of computing, right? Because mainstream computing never gave us what we needed. We always had to go and walk up to an object that got invented 7 years after we shipped our program and then say, you know, what are you? I need to manage you. So we always had to say, what is this object? What is its properties? What are those values? Iterate, and then turn something red or green or perform some action. And mainstream programming technology never really had that. It was always really about tight bound conversations. Well, .NET Reflection now gives us the ability to do that, but using a mainstream programming technology. The problem with the other stuff, right, that's what gave us CMIP, SNMP, DMI, WMI, all great stuff, but then to be successful, we got to go out to the community of the world and say, hey, now you support this, right? And then people just say, well, you know, maybe, or if I have to, right? Here's a trick. Go put in a newspaper ad, right? 2 newspaper ads. One, hiring CMIP programmers. 2, hiring C# programmers. See how many resumes you get. Now, take a guy fresh out of college. Say, hey, next 3 years, you're going to become an expert in DMI, SNMP, WMI, or next 3 years, you're going to become an expert in C# and .NET. And take a look at that person, and what do you think they're going to say, 5 years from now, what's my salary going to be? When I try and find a new job, how many doors am I going to knock on that someone's going to respond to? The answer is mainstream technology has a huge benefit. Yeah. So we're really doing, that's what's so phenomenal. I mean, the technology is really cool. It's awesome. It's great. But what's so cool is it's leveraging mainstream technology, which means, boom, it's going to just take off, right? If you fix the economics, right? It's all about economics, right? Everything's about economics. You're a technologist, I'm a technologist. We love technology. But technology that matters is technology that drives some economic difference. And that's what we've done here. I mean, I can walk you through step by step by step. Everything in this design is based upon some economic model, right? So in the programming, I never ask you to write a line of code that I can't clearly connect the dots to a customer value. And you know, anytime somebody asks you, comes to your office and says, hey, you know, we need you to support X or Y or Z, you gotta ask them that question. Tell me how my writing that code benefits my customer. If they can't, you ought to kick them out of your office, right? And I can. Every single line of code I ask, I can show incredible leverage. And I'm asking to write a tiny, tiny, tiny amount of incremental code beyond your managed code.
Name 3 things that you think are going to be the most popular uses of Monet. What are 3 things you think that people will do a lot with Monet? Oh,
sure. So 1, explore their system. Right? What's going on with my system? What's really going on with my system? You know, a lot of this has to do with you know, the questions that you ask or function.
Does that help security? Because now I can watch what my system, how my system is being changed.
Yeah, in the sense that, you know, security management, security, availability, diagnostics, all are premised on how well do you understand your system and what is it now. Okay, so right now it's kind of hard to get a good idea of your system, or how do you compare one system versus another? And so what it's going to do is allow you to make it very easy to ask questions. What about this? What about that? Hey, I see all the processes. How are those processes broken down by handle counts? What are the companies that are using the most handle counts? What are the versions of the files being run? What software? I can tell you which processes are using pre-production software. We can answer all those questions with the system. So the interactive ability to explore the system. Next is comparisons. Look, here's how it really works, right? When something goes wrong, I'll go off on a tangent, tell you a great story. When my brother was a little kid, right, he's taking a bath, he falls in the tub, breaks his arm, right? Oh my God, he broke his arm. So they bring him to the hospital. The doctor touches his arm, screams, go and take a bunch of x-rays. Nothing wrong. But he goes and he touches his arm. Does that hurt, Stephen? Oh, yes. He screams. Well, maybe I got the x-ray wrong. So they take his arm, they do a different angle, they take a picture, and the doctor's looking at these x-rays, and he's looking at the kid, and he says, Stephen, how high can you lift your arm? My brother says, so only that high. He says, that's really bad. How high could you lift your arm before? And he said, well, all the way up here. And so the point is that, you know, that's often how people manage their systems, right? They say, well, what's the situation now, and what did it used to be, right? And compare those two, and that gives you a little keen insight into what's really going on. And so what you're going to be able to do is you're going to be able to snapshot your systems, grab objects on the system, store them off in XML and SQL and CSV, and then grab a new snapshot and then just say, tell me how these things differ. Now look, you can say you can do that with Unix today. Oh, I do a PS and I do a PS. right? I do a diff, but that's a textual diff of a set of things. What I'm talking about here is an object diff. Hugely different. I can say, here's a set of objects and here's a set of objects. Compare them based upon their names. You say, oh, well, this list has these names, this list has those names, okay, and the rest are common. I can say, use the name as the identity field, but then tell me how they vary based upon CPU utilization or version. So what I can do is I can say, get a process list from this machine. I have 50 servers, and this one's a little wacky. Grab all the processes, grab all the processes of these. They're supposed to be the same. Tell me if there's any differences in the versions of the files that are running the executables. So the processes all look the same, but maybe there's a difference in the versions to run those processes. And I can answer that question. And you've had a heck of a time to be able to answer that in the past. I defy you to find a way to solve that today. It's very hard. And with this system, it's rock simple.
Was that 2 things?
That was 2 things. And the third thing will be to find information. So one is to manipulate the information. It's easy to get information, manipulate. The next is to find it. What we do is we surface all the stores on your system as a file system, or like a file system. It's actually richer than the Unix model. That's the Unix model. Make everything a file system. The problem with that is, what's a file system, right? It's a hierarchical name with fixed syntax, and then it's got an inode and a byte stream. Okay, well, that's great. It's served them extraordinarily well. Hats off. Great respect for that community. But we can do better, right? And what our notion of a file system or a namespace is, it's a hierarchical namespace where we do not impose a naming structure, right? So in X500 Active Directory, I don't know why, but they went and put the children on the opposite side, and they use commas instead of slashes. Fine, we support that. So too, when you find a location in a namespace, instead of having a fixed set of assets and a fixed set of informational axes, we have a rich set. So you have the content, you have the property, you have the item itself, you have its children, or its relationships. Right. So you can go navigate from that spot to other places in the system. And each of these can have an arbitrary set of properties. Right. So it's extraordinarily rich. So what does that mean? So I can show you how we navigate the file system. You can navigate into Active Directory. You can do a grep in Active Directory. Do a recursive search. You can go into the registry. You can go into your search store and start grepping around. DIRs.
What's the event that tells somebody they're ready to promote it? When do you take somebody like me and say, because I'm not a programmer.
Yeah.
I'm not. And I assume you're going to start broadening, programming to people like me. What's the event when I say I need Monad now?
So basically, it's like wisdom teeth. When you need it, you'll know it. You don't need to be told. And so what's really going to happen is there's going to be a bunch of early adopters. We already have a bunch on beta place. Oh my Lord, they are voracious for this stuff. Give us more, give us more. They're doing extraordinarily stuff with it right now. And what's going to happen is, over time, they're going to be the early adopters, and they're going to do wild and wonderful stuff. And then what you're going to start to see is, you're going to say, go to some community site and say, well, what I really need to do X. And somebody's going to say, boy, here's a 3-line Monad script, and it just does it. So then you'll say, hey, I'm not a Monad programmer. I just use Monad all the time. I use this script from this guy, I use that script from that guy. And then at some point you'll say, hey, that script is almost right, but it's not quite right. And so then you'll go and you break open that script and you'll change it. So we, in fact, have an incredible dynamic range of users, okay? The first is a simple CLI experience, okay? CLI, go, type the commands. You can be a very simple user and get some great stuff done. Next is simple scripting. So simple scripting, there's the Unix-style simple scripting of run existing executables, get their text, parse the text. We fully support that model. Next is kind of a WSH-style scripting, where you say, hey, give me a COM object, OLE automation object, invoke these methods, grab these properties, fully support that. But then there's the MSH-style scripting, where I say, hey, invoke these commands, nice high levels of abstraction, pipeline those objects into object utilities, have a rich set of conditionals and control structures, and then there's sophisticated scripting, We have full support for script blocks or lambdas, if you understand that idea. A very rich control structure, a la Perl 5 switch statements. Very rich structures, very tight control over scoping, lexical, dynamic scoping. Very, very, you can get pretty chewy with this stuff, but you don't have to. We support each one of those experiences.
It sounds like you were influenced a lot by Unix and Linux and
Well,
Macintosh. Yeah, I bet if we looked around neighboring offices, we'd find a variety of different operating systems and different approaches to this.
Indeed, most of the team has deep Unix experience, but and you can very easily connect the dots between some of the stuff we've done and some of the stuff Unix has done in the past. But to give them their due, the fact of the matter is we've looked at lots of different systems, and some of the strongest influences are some things that don't get a lot of mention in today's world, right? VMS. VMS is a wonderful system. VMS's DCL is very production-oriented. That's the thing I think it's fair to throw a rock at the Unix community. A little less focus on the production-oriented, maybe a little bit more focus in on cute and friendly, cute and witty versus let's get the job done. Same thing with AS400. Fantastic environment, and we have a number of those capabilities. So you asked about one of the things we do. What everyone is going to do is we have very rich targeting capability. So I say, give me the processes that begin with the, you have use a rich wildcards against processes, and we have both positive and negative masks. Give me everything that starts with an A but doesn't have an E in it, things like that. Okay, and then you're going to pipe that to stop process. But then the question is, geez, is that a good thing or a bad thing? We have a programming model that supports what we call the confirmation model. Confirmation model says, if you're ever not sure about something, if you're ever like, this is probably good, but if it's not, it could be really bad, you can say minus what if. And when you say minus what if, it tells you what it would have done, but then it doesn't do it. And then you can say, oh, I want to change it, do what if again, get it right, and then say, now do it. If it's hard to get it right, for whatever reason, hard to get the right expression, you're not sure, whatever, you can just say minus confirm. And when you say minus confirm, one by one, are you sure you want to do that one? Yes. You sure you want to do that one? No. You sure you want to do this one? Yes. Yes to all, no to all, or suspend. Suspend breaks you into a subshell where you can explore the system. What about this? What about this? What about this? Oh, I get it. Exit, come back to where you were. Now, what did you want to do here? You can say yes, no, etc. And that's stuff right out of the VMS world and the AS400 world. They're great environments. There's lots of great systems out there. The thing I would say is that they all tend to be very focused in on a particular scenario or a particular scenario. The problem with that is then the admin has this toolbox of tools that are inconsistent and don't really span things. Now, we're going to support the toolbox mode. It's extraordinarily powerful. But what hasn't happened is the thing that says, hey, let me step back here and take a look at the breadth of scenarios for the admins and try and get a tool that covers as many of them as possible. Now, yeah, it's going to fail at some point, but it shouldn't fail at the get-go, right? So awk, boy, if you'd just taken some of the control structures of awk and put them into the shell, it would have been a much more powerful shell experience. Same thing with Perl. Boy, if awk had a better built-in model, I wouldn't have had to do this. And now the user has, well, sometimes I do it in shell, and sometimes I do it in awk, and sometimes I do it in Perl. And it's really an inconsistent experience.